Cool.
All right.
You can see the layers.
So we're going down this cave, one step at a time. Is what it feels like. And yet, warmer than it should be.
As you can see, today's video takes me to a new low point, several hundred feet underground. I am here in the Guadalupe Mountains for the weekend, hiking and caving in this playground for outdoor enthusiasts and geoscientists alike. But how did these mountains and caves get here? 250 million years ago, during the Permian time period, where West Texas and southeast New Mexico are now, there was once a shallow ocean. In this ocean grew a large coral reef. As time went on, this coral reef became buried by other sediments, and the water level dropped, and eventually the ocean was gone. With the disappearance of the ocean, weathering and erosion took place, removing substantial amounts of rock from around this carbonate reef. This carbonate reef, now exposed at the surface, is what we call the Guadalupe Mountain range. Underneath the Guadalupe Mountain range are many layers of sedimentary rock which contain reservoirs of oil, petroleum. This petroleum, over time, gives off hydrogen sulfide gas. If we zoom in on the Guadalupe Mountain range, or my figure of it here, the hydrogen sulfide gas is rising up into the mountain at the same time that water is percolating down from the surface. The combination of hydrogen sulfide and water creates sulfuric acid. This sulfuric acid worked to dissolve the limestone within this mountain range, creating caverns and passageways, which gradually, over time, worked their way upward. The caverns seen on this trip were often dozens of feet tall, and some hundreds of feet long, with impressive calcite structures adorning the space. In most cases, caves will actually form from the top down as carbonic acid percolates in with that water. But in the case of the Guadalupe Mountains, we believe they formed from the bottom up because of the dissolution of limestone due to sulfuric acid, which was the result of the hydrogen sulfide gas. Over time, weathering and erosion processes on the surface of the mountain cause small portions of that cavern to be exposed at the surface, and this is where we can enter the cave system.
Rock! Thank you. Hey, it's my job to touch as many rocks as I can.
Often, caves like this involve dangerous climbing and rappelling situations. On this trip, we had to use ropes and climbing harnesses under the direction of several skilled guides. Please do not attempt caving like this without proper training, as it may injure you and damage the cave if you are not careful. The steep angled passageways and pits, like you see here, are the result of acidic water working its way through fractures in the rock, dissolving the limestone and causing it to crumble under pressure from above and the force of gravity pulling it down. Inside of each cave, there are formations which come down from the ceiling called stalactites, and formations which rise up from the floor called stalagmites. These two features form because as the dissolved limestone in the groundwater is pushing its way through the pores in the limestone, eventually they will encounter one of these voids, where this drop of water comes out of the roof of this void and kind of sits there for a while. Eventually, it's going to evaporate some portion of its water away. When it does, the calcite that was dissolved in it is left behind and precipitates as calcite crystals. As these formations on the ceiling grow over time, water can drip down off of them onto the floor beneath, which encourages the production of calcite formations directly underneath of the formations on the roof. So often we will see stalactites on the roof and stalagmites directly underneath of them on the floor.
We are at the end of Cottonwood.
What? Where are we at? No, I'm just kidding.
We are at the end of Cottonwood Cave, as far as we can go.
There's no cotton. I'm sorry.
There's no cotton or wood. There's no cotton or wood, but there are lots of stalactites and stalagmites around us, okay? So just do a sweep of my lovely assistant here is going to do a sweep of the cavern. Here are my caving companions, and you can see all of these beautiful calcite formations coming from the floor and from the ceiling. And this is what I was mentioning before.
I think you meant manly assistant.
Manly assistant.
Thank you.
That's what I meant. But what happens is this chamber has formed as all of the calcite has been dissolved by the groundwater. And as the calcite is dripping down through the pores in the limestone, it's precipitating tiny little microscopic crystals of calcite. As the water drips down, a little bit is left on the tip, and then the water falls down and forms a stalagmite. As the stalactite forms, the stalagmite forms underneath of it. And they form these concentric rings. Let's see if we can get a good shot on that. This is the interior of a stalactite. It forms those concentric rings of calcite.
You can kind of see it.
Yeah. And you might notice different colors in there, and that's probably because of different other things that the water may have contained. Perhaps it was a little bit of iron. Perhaps the calcite's a little more aragonitic. Whatever the case may be, it makes those different colors. But this is still calcite. It will still respond to all the different tests that you've learned in class. It'll still fizz with hydrochloric acid. It's still softer than glass, regardless of color or the way that it forms. All right, so we are here in the speleogasm room of the Pink Panther Cave. And you can see all these amazing formations. Stalagmites and stalactites. There's actually one just around the corner there, a huge one. Still dripping wet, still growing. And when you look up, these massive chandeliers of stalactite formations. Some of these things are so incredibly thin and delicate. All of this is, or at least some of this is still growing, still active. If you look up long enough, you can see water dripping from the ceiling. And as the bits and pieces of stalactites fall, you can see how they're getting incorporated into these, we call these popcorn formations down here. They're slowly being absorbed. You can see how beautifully translucent this calcite is.
The larger structures you see in these caves, which look like flowing water, are called flowstones. I know, who could have guessed? They form when large quantities of water fall from the ceiling instead of occasional drips. Any structure formed by gradual precipitation of minerals inside a cave is referred to as a speleothem. This includes flowstones, stalagmites, and stalactites. Perhaps the most exciting part of this whole trip for me was descending down into one of the deeper caverns of Pink Panther Cave, and there finding the skeleton of a short-faced bear, an animal which has been extinct in North America for over 11,000 years.
And his bones have just been preserved here and covered in calcite over all those years. Not sure how it got here. Maybe it entered the cave above and then died from a fall and then got washed here or something. This is too far down to be an actual den. But here it is.
What goes down must come up. If you are ever fortunate enough to go into a cave, please remember to respect and preserve the ecosystem and geologic beauty. Know the laws and rules which are in place to protect such natural wonders. Thanks for watching.